Bye. Have your lunch, all of you. So, in our course, now we came to the end. Our end of the topic is flip-flops. Right? So, before going to flip-flop, what is the preliminary concept of flip-flop? Why we are going for flip-flop? What is the need of flip-flop? Is flip-flop the only device to store one-bit storage informations? What is that? Yes, exactly. You are right. Latches, right? So all latches and flip-flops are combination of sequential circuits, sequential circuits, because in combination your output depends only with present input. In sequential, your output depends with both present and previous. So in order to store your previous data, we need a memory device. So the flip-flop, all one-bit storage devices having memory device is said to be a sequential circuit. Okay. So as Bhavana said, latches is the player device of flip-flop. So first we used latch, right? Latches, so why after latch, why we are going for flip-flop means in latches we don't use clock pulses. Okay, the only difference, latch is also a one-bit storage information device. Flip-flop is also one-bit storage information. Both are cross-coupled devices, right? So why we are going for flip-flop is in latches it has some drawbacks, like for using clock pulses, it is not much effective in using clock pulses. That's why we are moving for flip-flops. Okay. Just we had an overview yesterday about flip-flops. I think. What are the types of flip-flops? Yes. JK flip-flop. Yes. Yes. SR. JK. T. B. And what is the another one? Master. Yes, very good. Master slave. Master slave flip-flop. So SR is, S represents your set or represents your reset. Okay. So SR flip-flop means we can implement SR flip-flop by using all logic gates like AND gate, OR gate, OR gates, whatever gates we can, basic logic gates we can use. So our each logic gate has some function, its own function, right? Suppose the AND gate means it has logic multiple factor, right? OR gate means addition. Likewise, each gate has its own operation, right? So by using any gate, you can design SR flip-flop. So as we had already discussed, like design process and analysis process. What is design process? Combination is your design process and sequential is your analysis process. Design process means it starts with truth table and ends with logic circuit. Analysis process means it starts with logic circuit and ends with truth table, right? So here, now we are in analysis process. So SR flip-flop means set, reset. Based on the gates, your function will be performed. So if you are getting a clock pulse, if you are having we have excitation table, characteristic table, the function of SR flip-flop can be represented by using characteristic table. Very simple. In SR flip-flop, if you are using two inputs, two AND gates or OR gate, say your AND gate function will be carried. Okay. So if your output is 1, then the flip-flop is on. If the flip-flop is on, then it is said to be a set condition. Okay. If your flip-flop is off, then it is said to be a reset condition. For example, this is a flip-flop. You can take. If it is SR, your input will be yes, output. Two inputs are S and R, set and reset, and your outputs will be Q and Q bar. So if your output is 0, your Q and Q bar will always be vice versa, complementary term. If Q is 0, your Q bar will be 1. If Q is 1, your Q bar will be 0. So this is the structure of your flip-flop. So each flip-flop will be represented in same aspect. If SR flip-flop means S input, or input, set, reset, then Q and Q bar output. Same based on your bits, your flip-flops will be added. If 2 bit means 2 flip-flop, 3 bit means 3 flip-flop. That is 2 power n concept. Okay. So next JK flip-flop. Same like SR flip-flop, you can implement JK flip-flop This JK flip-flop also have some characteristic table equation. Hope everything we have shared yesterday and you might have all gone through that PPT. So everyone you know about that table, characteristic table and function of each flip-flop, right? And T flip-flop is toggle flip-flop. So if 0, 1 your output is complement. But if your output is not like that, if it is toggling 0, 1, 1, 0, then it is said to be toggle flip-flop. And D is nothing but data flip-flop or direct flip-flop. Whatever input you give, the same will be received in your output. That is said to be as data flip-flop. And master slave, MS is nothing but master slave. Master slave means whatever function the master is executing, the same will be followed by your slave. So this is all about the overview of a flip-flop, and you might have gone through the PPTs which we have shared, which I have shared in our WhatsApp group as well as in courseware about all the flip-flops, and you are supposed to come prepared on it, right, today? Is it or not? Can anybody come and explain these flip-flops? Can share your what you have understood about the flip-flops? Or at least any 4 flip-flops. Let us discuss about any 4 flip-flops. Anything? Yes, which flip-flop? Yes, very good. Please.
So nothing but basically they latch a group. Along with that, they are just adding 2 NAND gates. For the 2 NAND gates, they are giving 4. They are SNR is given as input for one of each one of NAND gate, and giving the clock signal as common input as budget. So once let's consider the situation where the clock signal is 0. So once when it is 0. So it will be S star and it will be R. It will be R star. So that is you will complement of this function. So when this clock is 0, it will be 1 and 1. So as we know that the given to output will be minimum. And once the condition is 1, we will have the 2-bit port rating, that is 0, 0, 0, 1, 1, 0, 1, 1. For 0 and 0, then the clock pulse is 1. It becomes 1 and 1 and also becomes as minimum. And once if we give 0 and 1, it becomes as 0. And if we give 1 and 0, it becomes as 1. And if we give 0 and 0, the clock is 1, the output would be S and SR would be 0 and 0, so the output would be not use function. Anyone interested to explain about the SI?
Ma'am, I was explaining about the JK flip-flop.
Yeah, very good. Please proceed.
So I'm going to give an outline about JK flip-flop. So what exactly is JK flip-flop? So it is a key element in flip-flop, and it has unique features compared to other flip-flops. So this is the circuit diagram of JK flip-flop. It consists of 2 inputs. One is J and another one is K. Then why it is named as JK? Because the inventor of JK flip-flop is Jack Kilby. So only it named as JK. So the truth table of JK flip-flop will be, if you give the 0, 0 as input, the output will be our fast output. So it will be known as a memory. So if you give zeros and ones, the output will be 0. If you give 1 and 0, the output will be 1. If you give 1 and 1, in the SR flip-flop, if you give 1 and 1, we didn't get any output. But here, if you give 1 and 1, you will get an output known as Q complement. So whatever will be the Q, the complement will be the output of 1 and 1. So the advantage of JK flip-flop is the toggle capacity. The disadvantage of JK flip-flop is it takes much time compared to other flip-flops. Then the main application of JK flip-flop is it is used in many digital circuits. So for example, shift registers and counters, etc., etc. So that's all.
Okay, good. Anyone interested for next flip-flop? Explain next flip-flop. Just let us discuss 2 more flip-flops. Yes.
Will we take the
Yeah, please.
Then I'm going to explain about D flip-flop. D flip-flop is a delay or data flip-flop in which clock pulse is given to both the NAND gates. Here the 4 NAND gate is used. Clock pulse is common for both the NAND gate, and D is given to one NAND gate, and for another NAND gate the D will be reversed by using the inverter. Then the output of this two NAND gate is given to the another two NAND gates. And if we gave D, if the clock pulse is 0, the output will be in memory. If the clock pulse equals to 1, D will be 0 means Q will be 0 and Q dash will be 1. If D equals to 1 means Q will be 1, Q dash will be 0. I am going to explain about advantage and disadvantages. Advantage of this flip-flop is easy and understandable. Then the latches take place at specific age only. Then it is used in counters and various flip-flops. Then disadvantage of this flip-flop is due to the inverter, the time consumes more and power consumption. Thank you.
Yeah, very good. The last one. I'm ready to take some information.
Let's see about T flip-flop. So it has one input. We have given the same input to the second NAND gate also, and clock pulse is same for both the NAND gate. So T flip-flop, the other name for T flip-flop is toggle flip-flop, which it means it changes its state. When we give input as 0, we will get the output as 1, and vice versa. When we give 1, we will get 0. So the advantages of T flip-flops are they are more simpler, and they can widely used in devices where toggling is required. And the disadvantages, it cannot be used for versatile instruments. So the applications are it can be used in registers and counters. Thank you.
Very good. I hope now you have a clear idea about flip-flops, right? All of it, like what SR flip-flop, JK flip-flop, D flip-flop, T flip-flop. Can we go for an activity? Okay, then with coordinating. Please come and explain. What we are going to.
I hope you guys understand the most of the flip-flops, but we are going to conduct the activity only on the T and D flip-flops. Okay. I have the various inputs written in the papers, the zeros and ones. Now I'm going to give you guys, ask you guys to form the characteristics table of the flip-flop only when the clock is high. Okay. I will show the example. If the input is 0, then what will be the output? The present state and the next state. Okay, present state will be 1 and 0. We're going to match, but we can only take one paper at a time from here to there, and you're going to match them. Okay, I hope you guys understand. If you have any doubt,
Mister,
who want to first thing?
this is other T. This local T, please. Let's try.
Okay, you guys are going to do this thing. Okay, E and D. Split between you. Okay, that's up to you guys. Okay, I'm going to check the time. What minute your time to finish this. Okay, and match upon we will discuss the winners. Okay. Okay, first who is going to do T? What will be the input and the present state and next state if the clock is high? And wait.
Yeah.
Next input, 2 inputs. The first output input and output present state and state on first line and second line. Inputs. You have to place a separate column for the input. Okay. Okay, your output was right before that. Okay, but you only have to add the, I only told you to add the inputs.
It is time up, then the sounds will next. Time up is can try next time. It's next team. This is try.
We will explain again. Okay, we are going to place the first inputs on first row with 3 columns of input, present state, and next state. Okay, and the next input, present state, next state. Okay. Ready? That is
Which flip flop you are going to? A flip flop. D flip flop. Delay.
what will be the outputs when the clock is high?
This table.
You can only take one paper at a time now. Ready?
Yes, very good. Thank you all. Hope you all enjoyed the class and the talk. So wish you all the best. Thank you.